Okay, just continuing 6.5. I wanted to leave this up here. This is one we did yesterday, just as a quick review. So the 75 we broke down over here on the right. Okay, we can break it into 25 and 3, which 25 breaks into 5 times 5. So there's a pair right there. So that becomes a square root of 75. So that's why we have the 5 outside. This 3, though, remember, has to stay inside our radical. Then the 2, we ask ourselves, how many times does 2 go into 12? 6 times. So what we're doing is we're pulling out 6 groups of 2. Okay, then with this one, I put the visual right here with the y's. There's 7 y's there. So we're looking for pairs, right? Because we're working with a square root. So there's a pair of y's, there's a pair of y's, there's a pair of y's. We have 3 pairs. So y cubed, but this lonely little guy right here has to stay inside the radical. Okay, and that would be our simplified expression. Okay, any questions on that from yesterday? Okay, that's going to tie in directly to what we're doing today. We're still going to be simplifying things. We're just adding some other elements prior to. Okay, so this is where we're going to pick it up. This was in the bottom row of your note sheet, right in the middle. So what we talked about yesterday for this quotient property is I can take this cube root and just apply it to my numerator and apply it to my denominator, just like that. Then we're just going to simplify the numerator and the denominator like we know how. So 24. Does 24 have a cube root in it? Well, the reality is, guys, we just have to accept the fact that we're going to be doing some side work. That means some work where you go over to the side of your paper, you do some of the math in order to figure it out. Okay, you just have to accept that. So I'm going to go over here, 24. I know I can break that into 8 and 3, and then this can break into 4 and 2. And then I can break that into 2 and 2. Oh, there, right there. There's my group of 3, right? Okay, because I'm looking for groups of 3, looking for cubes. So I know that 2 is a cube root of 24. So I'm going to put that 2 outside. But then I still have a cube root of 3 left over inside, because I have this 3 left right here. Okay, now we're going to do the a's. So how many times does a go into 6, or 3 go into 6? 2 times. Remember what we're doing, 1, 2, 3, 4, 5. There's 6 a's right there. That's 8 of the 6th, right? We're looking for groups of 3. So there's a group of 3 right there. There's a group of 3 right there. How many groups did we make? 2. Are there any left over? Nope. So that means we can pull all of them out of the radical. So we have a squared out here. Then on the bottom, does 125 have a cube root? Think about the factors of 125 that are square numbers. Josh? 5. 5 times 5 is 25, times 5 is 125. So our denominator is just going to be 5. And that's our simplified expression. Okay. I want you to try the next one. Okay. On your own, I will tell you that 256 does have an even 4th root. Okay? 16 times 16 is 256. Okay, so that means that 4 times 4 times 4 times 4 is 256, right? So the 4th root of 256 is 4. I'm going to tell you that part. The rest of it I want you to do on your own. Okay, can we break that 80 up? Yep, what can we break it into, Dylan? Yep, 2 times the 4th root of 5. Okay, so I'm going to put a 2 outside. Like that. Okay, now what about the y? Y to the 14th. Can I simplify that? Yep, how many times does 4 go into 14? 3 times. So that's y cubed with how many left over? Y squared. Good. Over 256. It's 4. So we know that goes outside. Okay, what about the z to the 4th? Do we have a 4th root of z to the 4th? It's just z. Okay, just like that. Now, here's the last thing that we have to see. We have to see this right here. That's 2 over 4, right? 2 to the 4, or 2 over 4 can be simplified to what? 1/2. I divide this by 2, it turns into a 1. Divide this by 2, it turns into a 2. So my final answer is y cubed times the 4th root of 5y squared over 2z. Moving on to our next one here. Okay, we're going to start adding and subtracting radicals. This is on the back of your note sheet. So flip that over. This is really similar to a skill you've been using since middle school. Okay? If I went like this, 2a plus 3b plus 2a squared plus 7b squared. Are there any of those that we could add together? Or any of those like terms? None of them are, right? Okay. Now, this one right here is a 2a, and this one has an a, right? But this one's raised to the second power. So they're not like terms, right? Okay, same thing with the b's. What if I went like this, and I said, all right, this is raised to the second power. Now could I combine those?
Yes.
Yes. Now I combine 2a squared plus 2a squared, and I get 4a squared. Okay, the same concept really applies with our radicals. Instead of talking about a variable, a or b or z or x, we're talking about the number inside the radical, the radicand. Okay, and instead of the exponent, we're talking about the index on the radical. Okay, those things have to be the same. Okay, so if I have, just for another example problem, 2 times the 4th root of 5 plus 3 times the 4th root of 5. Do we have the same radicand? Yep. Do we have the same index? So I can add these together. Okay, so 2 plus 3 is 5. So if I added this together, it would be 5 times the 4th root of 5. Okay, so now go into our next problem. Right now, the way it is right now, are there any that have the same radicand? No. Do they have the same index?
Yeah.
Yeah, they all have the same index. They're all square roots. But what we have to do here is, again, accept the fact that we're going to have to do some work on the side. And we're going to simplify the square root of 45x, the square root of 12, the square root of 20x. We're going to simplify those and see if we can get it to have the same radicand so that we can combine some things. Okay? So over on the side, this is what you're going to do. You're going to grab your pencil. We're going to break 45 apart. We're going to break 12 apart. We're going to break 20 apart. Okay, so if we break those apart, we find out that each one of these does have a root within it. So the 45 is going to turn into 6 times, what's the root that's within 45? 3, right? So we're going to put 3 outside times the square root of the 5 stays in here, x. Okay, why did the x stay in there too? Why weren't we able to pull the x out? What if it was 45x squared? Then would we be able to? Does x squared have a square root? Yeah, it'd be x, right? It doesn't, so we have to leave that x in there. Okay, now the next one, we're going to do plus, and then the 12. The 12 we broke down into 2 square root of 3 And then the 20 we broke into, it's going to be minus 3 times 2. And then we have the square root of 5x left over. Okay. Now, at this point right now, it doesn't look like we've simplified. It looks like we've made it more complicated, right? But really, we need to go in here and say, oh, well, 6 times 3 is what? 18. So that's going to give me 18 times the square root of 5x plus the 2 square root of 3. I can't change, so that's going to stay the same. 2 square root of 3 minus, what's 3 times 2? 6 square root of 5x. Now looking at those three, are there any terms there that we can combine that have the same radicand and the same index? The blue and the pink, right? Okay, this one and this one. Now notice when I circled the pink one, I also circled the sign with it, right? I need to know that that's a negative 6. 18 minus 6 gives me 12, right? So that's going to be 12 times the square root of 5x. And then the 2 square root of 3 stays the same because there's nothing to combine it with. Any questions on that? Okay. I want you to try this one on your own. I will tell you that the first three you can simplify. The last one you can't. It's got 7. So you just have to leave that one alone. Okay, let's look at it. The 18, square root of 18. We've got to go do that side work, right? So we're going to break that 18 apart. 18 can break into 9 and 2, 3 and 3. Oh, there we go. So I know it's 3 times the square root of 2x. The x has to stay. All right, now the next one, 28. 28 can break into 7 and 4. Oh, there's my root right there, 2. Okay, so I've got 5 times 2 times the square root of 7. All right, now let's do the 98. 98 is 49 and 2. 49 is 7 and 7. Okay, so I know that this is going to be minus 3 times 7 times the square root of 2x. Because 7 is my root, and I have a 2 left over, right? Okay, then the last one we just have to leave alone. Were we able to get to that part? Okay, now we have to do our multiplication. So I've got this right here and this right here. So let's take care of that. 5 times 2 is 10, right? So it's going to be a negative 10 square root of 7. 3 times 7 is 21, square root of 2x. The others stay the same. Now we look for a like term. What is something we can combine here? Yeah, I've got this right here. I've got this portion because it has the 2x and this one. So let's do those first. It's 3, positive 3, and negative 21. So that's going to give me negative 18 times the square root of 2x. Can I combine those others? But they both have a 7, guys.
There's an x.
That x matters? Yeah. Okay, that x underneath the radicand, it matters. It's a different value. So we can't do anything with the other ones. Negative 10 square root of 7 plus 3 square root of 7x. That's our final answer right there. Okay, I'll say this again. We just have to come to grips with the fact we're going to have to do some side work. Okay, it's going to take a little bit of time. We're going to write down a lot of numbers. Okay, but if we go through the right process, I'm confident that you guys can simplify these things. All right, your homework. Oh, we're not there yet. Okay, we're going to start with the FOIL method. Okay, so FOIL method takes you back to probably Algebra 1. X minus 3 x plus 2. Okay, and what you did is you did first, so x times x is what? X squared, right? Okay, then you did the outside. X times 2 is 2x. Do you guys remember doing this?
Yeah.
Okay, now our insides, negative 3 times x is negative 3x. And then the last one, negative 3 times 2 is negative 6, right? We're going to do the same thing. Okay, FOIL actually stands for first, outside, inside, last. Okay, and something I usually do to just help make sure that I got everything right is I make mine looks like a little smiley face. Like these are the eyebrows, the nose, and the mouth. Okay, that's just how I do it. I do my insides and my outsides on the bottom. I do my first and my last on the top. Okay, so that's what we're going to apply to this. When we do that FOIL method, what operation were we doing? When we distribute, we're doing what operation? Starts with an M. Multiplication, yeah. So this is just multiplication. So when we multiply, as long as we have the same index, we just multiply the radicand. So this would be the cubed root of, what's 6 times 2? 12. Okay. The next one is going to be right here. Now we have the cube root of, what's 6 times 7? So minus the cube root of 42. I know, everybody got excited. Okay, then we do our insides. That's going to stay the same. So plus cube root of 2. And then our last. Okay, that's going to be minus cube root of 7. So now we have 4 terms. I forgot my cube on this one. Cube root of 12. Think any of those can be simplified? 42 seems like it would be able to, right? But we're talking about cube roots. 42, 6 and 7, 3 and 2. Do we get any groups of 3?
No.
No, we don't. None of these can be simplified. This is our final answer. That's it. Okay, so that's using the FOIL method. The last thing we're going to do is multiply. Okay, this is not the FOIL. Okay. Yes. Yeah, go ahead. All right. We're going to multiply 3 and 4. Okay, what's 3 times 4? 12, right? Okay, now we're going to multiply 10 times 16. 10 times 16 is 160. My radical is going to stay the same. So it's still the 5th root, but it's just negative 160. Now we're going to multiply our x's. When we multiply with exponents, what do? We add them. So it's going to be x to the 6th. Then we're going to do our y's. 6 plus 4 is 10. Y to the 10. So now we've multiplied. Now we're going to simplify. So we need to think about 160. Can we break 160 down into a 5th root? I want you to try to do that. So over on the side, we're going to take that 160, and you're going to build that factor tree. Go. 16 can be broken into 16 and 10, 5 and 2, 4 and 4, 2 and 2, 2 and 2. Oh, there we go. We got 5 2s, right? So I know that that's going to go with it. Now, here's the thing we have to remember is that because we're actually working with the negatives, 160, these are all negative 2s. Okay? So what we're going to pull out is a negative 2. So it's going to be 12 times negative 2 times the fifth root of, because we still have this 5 left over here, we've got to put that inside our radical. So the fifth root of 5. Okay, now we're going to do our x's. How many times does 5 go into 6? 1 time, right? So I need to move my radical over here. Goes in 1 time, so I'm going to take 1x out and put it right here, but I have 1 left over on the inside. Same thing with my y's. How many times does 5 go into 10? Twice. So I'm going to have y squared on the outside. And no y's left on the inside. So my final answer, I need to multiply 12 times negative 2. What is 12 times negative 2? Negative 24 x y squared times the fifth root of 5x is our final answer. Questions on this one? Mr. Nooch, how did you, why did you, where did you, what happened to? Going once? Twice? Sold. We're going to skip that one for today. This is your assignment. It's already on Google Classroom. Heads up, this 329 stuff, that's what we did yesterday, where it's going to give you like a function, y equals the square root of x minus 3. Okay, so just heads up on that.